Hello and welcome to another tutorial. Today the topic that we are going to be learning is scientific notation. Okay, before we get into the math, I just wanted to quick show you what it's like in Minnesota right now. It is crazy. Minnesota, March is still winter, definitely doesn't start really getting warmer until April, but this winter has been absolutely crazy. So I know I showed a picture a while ago of the snow, but compared to my dog now, it's even taller. There's my house way back there. You can practically barely see it. Here's a picture I saw on Facebook the other day. This is in a parking lot when they put the snow together so people can drive around. This is insane, the amount of snow, and it keeps snowing. It snowed again this weekend. I can't believe it. So feel lucky that you are in a place right now that is a little bit warmer than where I am from. Okay, so anyway, back to scientific notation. Scientific notation is a way that we write numbers that are either very big or very small. If you have not used scientific notation yet in science class, I'm positive that you will sometime in the future. Scientific notation is super common in science, so this will definitely help you when you get to working with scientific notation in science class. The general form of how we write numbers in scientific notation is a times 10 to the power of n. And so what these variables mean is a is a number and it needs to be between 1 and 10. So it has to be at least 1 and smaller than 10. So like 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. And then you're multiplying it times 10 to the power of an exponent. Here are 3 examples of numbers written in scientific notation. They are in scientific notation because the number that we're multiplying, it's bigger than 1 and less than 10. So all 3 of these here fall between those range of numbers, and you're multiplying it times 10 to the power of any number it could be. These, however, over here, these would not be examples of scientific notation. The reason why these are not examples is because each of these numbers does not fall between 1 and 10. Here we have a number that's bigger than 10, so that doesn't work. Bigger than 10, it doesn't work. Here this number is less than 1, so these would not be examples. So there are 2 ways to write numbers. We could either write a number in scientific notation or we could write a number in standard notation. And we can go back and forth between these 2 different ways. So let me explain exactly what each one of these parts of scientific notation means. Let's first take a look at this second example actually. So we have a number between 1 and 10 multiplied times 10 to the power of 9. So to refresh your memory, this exponent here tells us how many times we're multiplying 10. So we are doing 4 67/100 times 10 times 10 times 10 times 10 times 10 times 10 times 10. We're multiplying it times 10 9 times. When we have a number and we multiply it by 10, maybe you have learned in the past that when you multiply it by 10, it's like you move the decimal point 1 place. So if you're multiplying it by 10 9 times, it means you're moving this decimal point here, you're moving it 9 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There's the new location of your decimal point, and each little place here we can fill in with zeros. So that is how we get from here to here in standard notation. Now let's take a look back up here at the first example. So when we had this positive exponent, we are moving the decimal point to the right because the number is getting bigger. We're multiplying it times 10 9 times. When we have a negative exponent, remember negative exponents tell us instead of multiplying, we are dividing. So in this example, we are dividing by 10 9 times. So if I'm dividing by 10, that means I'm going to be taking this decimal point here and moving it to the left. So if we have -9, that means I need to move the decimal point to the left 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's the new location of the decimal point. I will fill in each place with a 0, and that is how we got from here to here in our new standard notation. One more quick thing I wanted to point out is notice how when we have a negative exponent, we have a really small number. We have a number that's less than 1. It's 0 point something. When we have a positive exponent, we have a number that is bigger than 1. So that's going to be a clue as to what kind of exponent we should have. Negative exponents go with very small numbers that are 0 point something. Positive exponents go with big numbers that are bigger than 1. Let's then look at a couple examples of how we would change from scientific notation to write the number in standard form. So the first one, we have 6 32/100ths times 10 to the power of 9. So that means I'm going to take the decimal point, and it's a positive 9, so I will move it to the right 9 places. So I'm going to rewrite this down below so I have room to move the decimal point, and I will move it 9 times to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's the new location. Fill in with zeros, and then we can rewrite it. It equals then I'll fill in with my commas, going every group of 3 starting from the right, comma, 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 and there's the final answer, 6,320,000,000. Next one, 4 times 10 to the power of -7. We have a negative exponent, so that means when we have our start here, the 4, we're going to be moving the decimal point to the left. When we have 4 wholes, we have, I guess, kind of like an invisible decimal point here. If it's 4 wholes, the decimal point would be right here. And now I'm going to move it 7 places to the left. 1, 2, 3, 4, 5, 6, 7. And fill in each place with a 0. Then I will write my answer. I'll put 0 point and then the decimal. And that is how we change from scientific notation to standard form. The last part of today's lesson is going to be going in the reverse way. So we start off given standard form, and we need to change it to be in scientific notation. So scientific notation, we should have a number times 10 to the power of something. So remember, this number needs to be between at least 1 and less than 10. So what we're going to do is we'll start where the decimal point currently is. And in this first example here, the decimal point is at the end of the number. It's a whole number. So we have an invisible decimal point here. And then we're going to move it until we get to a number that is at least 1 and smaller than 10. So I'm just going to see how many times I need to move it. And right here, if I put the decimal point there, it would be 2.01, which is bigger than 1 and smaller than 10, so it fits the requirements. So right here is going to be the location of the decimal point. So it would be 2.01, and I have all these extra zeros at the end. Well, in a decimal, when I have zeros at the end, it doesn't change the value, so I don't need these. I can just get rid of them, and this number I'll fill in here will be 2.01. And then my exponent, I'm going to count how many times I needed to move the decimal point. I moved it 1, 2, 3, 4, 5, 6, 7, 8 times. So my exponent will have an 8, and then I'll decide if it's positive or negative. Remember, positive exponents are for numbers that are bigger than 1, and negative exponents are for numbers that are like 0 point something. So we have a number here, 201 million, that is much bigger than 1. we are taking this 2.01 and we're multiplying it, making it even bigger, so we should have a positive exponent. Let's do the same idea now with the next one. So we have this number here in standard form, so we're going to have to change it to be in scientific notation. So in the end, in scientific notation, we'll have a number times 10 to the power of something. We'll start off at the decimal point, which is already written for us, and we're going to count how many times we have to move it to get to a number that is at least 1, but also smaller than 10. So let's see, we have to move it 1, 2, 3, 4, 5 times. So my exponent will have a 5, and this creates this number here. And when I have zeros before a whole number, they don't really matter. They don't change the number at all, so I don't need that. So my new number is now 5 1/10, 5.1, times 10 to the power of 5, but then we need to decide, should this exponent be positive or negative? We're starting off with this number that is 0 point something, so it's less than 1. We're taking 5.1 and we're making it smaller. We're dividing it to get a smaller number. So if we're dividing it, this should be a -5. And that's how we change these standard form numbers to be in scientific notation.